Hello, everybody. Welcome. It is Thursday, March 1st, 2018. This is the Kubernetes SIG Architecture full meeting. Today, I'm your host, Jay Singer-Dumars from Microsoft, and co-hosted with Brian Grant from Google. We are going to be following along an agenda that is available after the fact at bit.ly/sig-architecture. So if you want to see what we discussed and so forth, it's all in there. And today we have a lone agenda item presented by Daniel Smith at Google. Do you want to go ahead and take it?
Just one agenda item? Does that mean I get an entire hour?
More or less, yeah. This is a pretty deep topic. It's a pretty big but super important change to the API. It's something we've been discussing since almost the beginning of the project. If you want to dig down through or across the GitHub history, start at 1178 and go from there. It's going to be, I think it's one of the unique features of Kubernetes. Yeah, the good old 1178. SIG auth lead, I assume, is Clayton. Anyway, I mean, it's everything doing declarative management from kube control to Helm to UIs to cluster add-ons to even eventually, I hope, controllers like MetaController that want to assert properties of resources without controlling or clobbering the rest of them. Really need to have this pattern super well supported. So this is really critical. We are trying to get it to move forward as quickly as possible. I also just want to put a plug. I wrote an overview of Kubernetes resource management. I'll put a link into the notes. Just waiting for feedback from one person before I create a PR. But this is, I view this as a key component of that model. So anyway, take it away.
Yeah, so I think I have, without further, can you let me share my screen? Because I have some slides. It says host disabled screen sharing.
Let me see if I can fix that for you.
Yeah, I've got a slide deck. I have two design docs, which I believe have been circulated in SIG apps, CLI, and API machinery. And I know at least one of those design docs I sent to the SIG architecture list.
Okay.
And I have another document I'm working on, so there's like 50 pages of supporting material behind these slides.
Unfortunately, I can't seem to make this thing share for whatever reason. I don't know why that's doing that.
It says host disabled.
Weird. Let me try this. I'll just make you the host. I've got the record going. So,
okay.
Okay, there you go.
This is host disabled. If I'm the host, maybe I can re-enable.
It says Brian Grant is host.
Yeah.
I'll see if I can do something about it. Although I don't know what I'm doing in Zoom.
This happens to me every API machinery meeting. Not this problem, but random ones.
Yeah, Zoom is amazing for its plethora of random problems.
Does anyone know where that option would be?
To share screen?
To allow other people to share screens?
Oh, I give it to you so you could share the doc.
Yeah, it's actually the slides are on my computer, not Brian's.
Oh crap! Brian, can you make Daniel the host then? If you click on his picture and say make host. I'm sorry, I thought for some reason you guys were in the same room.
We are in the same room, so that's probably why.
All right.
Okay, you're host now. You should be able to do it.
Yeah. Okay. Let's try this. Yes. Okay. Can everyone see that?
Yep.
Yeah.
Can you still see it?
Yep.
Okay. This way you don't have to look at all the comments people leaving on the slides. So this is, I called this advanced configuration management. This is about kube control apply or fixing kube control apply. Should I go through the background carefully? Do people on this call have sufficient background here, do you think?
Yeah. Let's skip some of the background.
Yeah, okay. So you know what it does. I'll briefly say why I think it's good. I have 3 reasons here. It helps users build familiarity with the actual API resources, which means, if you have a system of tools that work together on API objects in the same format, then it's easier for users to understand if those tools are doing the correct thing. You can introspect any step in the pipeline and see what's going on. If you switch to an API client, you know what resources you're going to be building. So it helps users understand how the system works. In contrast, some other systems, users learn a special config language, which then generates the API calls. And I think that means users have to learn 2 confusing things. If from the perspective of system integrators, you end up integrating with one API. You make one API call with varying data and destination, instead of having to learn how to make a API call for every operation for every object. So it's significantly less effort in those terms. And finally, if you've read Brian's declarative app management document, as he mentioned, this is a essential building block. It doesn't really work without this concept. Control apply is not good for things that are imperative commands. It is for declarative management. So if you're charging a credit card or launching missiles, it's not a good idea. Some things can be phrased both as imperative and declarative commands. So if you send an RPC that's like open the pod bay doors, like that's imperative, but you could also have a like pod bay door position equals either closed or open. So you could do it either way, right? For some things. But for imperative things, this is definitely not your pattern. Which, some like Kubernetes infrastructure management is very well suited for declarative management. So that's why we have the system. Why is this hard? It is hard because we have to figure out what the user wants to do. And that's always hard. So in order to make it possible or easier to figure out what the user is trying to do, we may need to restrict the API surface area to certain patterns. And the goal of this whole concept is to allow users and systems to cooperatively determine the desired state of an object. Users make some changes, systems make other changes, and together you get the state that you want. And the goal for this particular design is that we want the control plane to deliver this solution. Today, this is implemented in strictly client-side. I have some non-goals like any good design. Control apply today does both multi and single object apply. I'm focusing only on the single object case. The multiple object case has additional complications. So for now, I intend to let that remain a client-side loop. I'm not currently, it's a little bit in flux actually, but at the moment I'm not planning on providing an API that does solely a merge of API objects. I think it's necessary in the future, but there's enough work to do, and that it's pretty clear how to build that after we implement the rest of this. So I'm leaving that for the future. Some sources of user confusion are not fixable by moving things to the control plane. It's unfortunate, but our data model is that the name and namespace inside a manifest identify the thing that you want to change. So if the user changes those and expects the object in the cluster to get renamed, they will be surprised. I can't really fix that in the control plane, so we have to figure out documentation. We have to figure out other things. There's also some landmines in some of our API objects with fields that you can technically change them but may not do what you expect. So that was also, we should fix that generally, not just for apply. So I'm not treating that as part of this effort. Okay, so I've broken this into 2 chapters. The first one is about what I've called user intent lifecycle management. And these are some example problems that I want to cover in this section. I don't know how much you've played with kubectl apply. There's an excellent talk from a CoreOS engineer. I want to say Aaron, but I don't want to get the name wrong. From KubeCon in Austin, Texas. I think it's the dark art of kubectl apply. That goes through some of the ways users are surprised by kubectl apply. There's a lot of ways to be surprised, and these are all ways that aren't technically malfunctions of kubectl apply. These are the user is following the wrong workflow, and we don't really detect that and help them not follow the wrong workflow. So I won't read the slide. Why is it hard to get this right? We've been working on it for, I say 2 years on the slide, but I think it's basically since the beginning of the project. A bunch of smart people have been working on it, and it's still broken. I have 2 primary reasons. The first one is like very practical, which is just too much stuff has to change in order to get the thing fixed. You have to change maybe you need to change the schema, which involves changing the types.go file and like our schema building toolchain. Maybe you need to change the strategic merge patch format. You need to change kubectl. You need to change maybe some other server-side machinery. It's like at least 4 components that you have to mess with to fix anything about kubectl apply. And then after you've figured all that out, you have to wait 2 release cycles to deprecate the previous broken behavior. So the rate of fixes and the skill set you need to make a fix is just, both of those things have combined to make fixes arrive at a very slow rate. The other problem, and I hope to fix this problem right off the bat with a comprehensive design doc, is that the system has evolved organically, and there hasn't been a systematic approach. Developers haven't known how to fix problems, so fixes have gone in various directions. Hopefully just having a big design doc that lays out all the use cases is enough to help with that problem. Okay, so now I have this is the slide that we get stuck on in all of my SIG meetings. It's the slide listing all of the components of the proposal. So I'm going to try to touch each one without talking about details. I have slides to talk about details following this one. So just very briefly listing all the things that we want to do. Clearly, the apply logic is going to move to the control plane with a new API verb. We'll have to add a dry run mode. My proposal is that we track multiple last applied states with a workflow ID. This was called client ID yesterday. I've renamed it to workflow ID because it is identifying the workflow that produces the config, not the user or the client. Usually that's how you want it to work. The last applied annotation, the last applied state used to be stored in an annotation. I want to make that a top level field under metadata. Sorry, I should say a first class field under metadata. We're going to default to giving users errors if they try to conflict, if they try to overwrite a field that some other system is managing when they use apply. Today, it will just clobber your object, and maybe you'll get a warning. Maybe you won't even get that. I have a few mechanisms to detect when users are sourcing manifests incorrectly. So if I do a get, I modify something locally, and then I do an apply. If you do that today, you end up managing a bunch of fields that used to have like default values or values set from other parts of the system. The user doesn't actually want to manage those fields, but that's what you're doing if you follow that workflow today. So I want to detect that. And in order to do that, we'll be needing to add some extensions to we'll probably be needing to add some extensions to the open API schemas that we use. In the future, not necessarily as part of this proposal, but in the future, I want the other API verbs in the control plane. Actually, this maybe is part of this proposal. Other API verbs in the control plane need to interact with the last applied states that apply stores. Because it doesn't really matter how you're making a change if you're conflicting with somebody. and you're a user, you probably want to know about that. Yeah, let's see. Doing it this way allows us to make bug fixes in one component. We still have to worry about the deprecation cycle, but hopefully it will greatly reduce the number of systems you need to fix to make a make a fix. And the ultimate goal is that kubectl apply is no longer just in kubectl, but other clients and other languages can use it. Ideally, you should be able to run an apply operation with curl if you really wanted to.
And it should work for extensions like CRDs and.
Oh yes, yeah. Today
version skew should work.
Yeah, version skew is in the document and not on the slides. Yeah, and CRDs, kubectl apply does not work for CRDs today. Even if you supply a schema, that could be wired through such that it would work, but then you would have all the bugs that because there's no place in the OpenAPI schema for you to state like the merge key behavior or whatever.
Yeah, it works just as simple merge. It doesn't have the full behavior of our merge keys and things like that.
Yeah, but I think that's a pretty critical. I think that's a pretty critical part of the system. But I guess it depends on.
Are you going to talk about the schema complexity in this presentation?
That is chapter 2.
Okay.
Yeah, the actual diffing logic.
Yes.
Yeah, that is coming up. If I get to, I've never gotten to that half of the slide deck, so we'll see if we make it. So more about the apply verb. I independently. This is also in Clayton's older proposal, but I wrote this down before I remembered I had read that, which is the reuse the patch verb and set a content type. This is a change from, well, it's kind of a change from our existing patch path. I think our puts can sometimes result in the creation of objects. No, none of them? I'm pretty sure some of them allow this.
Okay. We have a long-standing issue that we intended it to, but it's definitely not consistent.
Yeah, it's definitely not consistent. There's an option in the strategy that says allow create on put or not. So this will definitely, because I want clients to use the apply verb no matter what. So we'll have to allow that to create objects. I even say that redundantly in the slides. I have to fix that later. On conflicts, return helpful error messages, support dry run. I mentioned that already. This should be interesting for authorization because we'll have to run through either create or update permissions. Multiple appliers.
I think you would just authorize apply.
Authorize apply?
Yeah.
Would that be a new verb in the authorization system?
If we are treating it as a verb in the API, probably so.
And that would imply both create and update permissions?
Why couldn't we just reuse the patch?
Patch doesn't let you create things today.
Are we sure? If there are some things where put allows creation, I'd be surprised if patch.
Yeah, that's
on those objects. It does. I think only endpoints support that.
Okay.
Okay. Yeah, that's something to look into. So I'm still debating a little bit on this particular point. It's my feeling after looking through this that apply is just a more general and convenient mechanism for making changes than patches. So I would like to gradually roll things over from using strategic merge patch to use the apply format. Whether that means controllers explicitly call the same apply verb that users call, or if there's some differences in defaults, like I believe that controllers should typically win conflicts and users should typically get an error message unless they force. My general theory on that is that we should shuffle the error messages to users and not to controllers, because users are likely to read them and maybe understand them depending on who wrote the error message and do something intelligent, and controllers are likely to just try again. So it's best if we give users the errors.
Users will have to tell us, because even tools like Keep Control and Helm and whatnot can be put into automation.
Yes. Yeah, everybody needs to handle errors. I think there's a better chance of the user handling the error more intelligently than, like I know for sure that deployment controller or node controller, or like all of our built-in controllers, are just going to repeat their operation if they get an error, and then go into a hot loop and use a bunch of CPU and page me. So I don't want that. I don't literally get paged, but I hear from people who do. Tracking, so tracking multiple appliers. I didn't update the slide by workflow ID. Allows us to generate a bunch of useful error messages. Think of this as git blame, not as like a stack of patches that add up to the object state. I specifically don't want you to think about these as a stack of patches that you can add one after the other and get the current object state, because that means we have a problem. Like, what if one of the patches in the middle changes and all the ones afterwards are invalidated, and those might have been generated by like offline systems or things that you can't easily go out and query online to regenerate. So it's just not workable.
It's like container image layers.
Yeah.
You have to rebuild them all.
Yeah. It's like building a Docker container. If you want to put your the stuff that changes in the lower and the top layers, so that you don't have to rebuild the whole thing. I think maybe Brian will correct me if I'm wrong, but I think the primary recommended use case is for users to have a CI/CD system that users check in the exact objects. Perhaps there's some overlays, and then there's a system that just runs apply on that in a loop, stating that this is the like CI/CD system as the workflow ID. You can do other things, but I think that's going to be the most common. More about moving the last applied annotation to a top-level object. Here's another slide I forgot to change client ID to workflow ID on. Any questions about this concept?
Would we see that getting converted when you requested different versions of the object? So would the encoded objects always match the version of the object that they were returned in?
That is a really good question.
The answer is yes.
Brian thinks yes.
And the answer is yes. So currently, because they're effectively opaque string blobs that the API server doesn't know about, we can't really convert them. And also, doing it on the client, we don't really have a good way of ignoring defaults and things like that. But since we have the rule that all API versions that you can convert among must be, the conversions must all be round tripable, the schemas all have to be isomorphic to one another. So you should be able to always do a schema transformation regardless of default values.
They're always round tripable, but that can require defaulting.
No, it cannot require defaulting. If it requires defaulting, that's actually a bug, in my opinion. In that particular conversion code, the defaults are associated today with API versions. They could, in theory,
if you don't require defaults, then that means you can't ever add a field, right? Because adding a field to a new version means you have to add a field to an old version, and to round trip, then you have to have the implicit behavior default. These
are patches. So by just, since it's not a stack of the full of things you can compress to get the full state, the defaults are not in one of the patches. They are captured in the state when the resource is created. Only the creation operation, the version, only for the creation operation, the version actually matters.
Okay, so these aren't, encoded object is not a full object. It's a patch, is what you're saying.
These
Correct.
are, yes, these are patches.
Yeah, these consist of, I mean, it's not in the patch format. It is in the regular object format, but it only has the fields that the user filled out, even if other fields are required.
I'm not sure those are round trippable, but
I'm asserting that if they're not round trippable, it's a bug, right?
Yeah.
The schemas all have to be isomorphic. So you should be able to translate a set of fields to another set of fields.
Entire objects have to be round trippable. I'm not sure about partial objects, especially when you get into things like the selector stuff that we had, where one version only had the labels and another version had labels and complex selectors.
Yeah, I mean, so my opinion is that all that complex defaulting stuff was a mistake, and we backed out of some things like selector mutability and apps v1, and we can constrain it more for people using the apply flow. Okay. We can either do it for all apply operations, or we can do it for, we can provide an option to do safe applies that that actually validates that you're not relying on squirrely behavior.
Yeah. All right.
But yes, I mean, if you, it's not intended that you should be able to reconstruct the same object strictly from the these last applied strings. So if you converted to a new API type and you extracted the string you think you applied and you recreate the resource through a different API version, you would get different. You could very well get different defaults. I consider that to be acceptable.
It wasn't clear to me whether encoded object was intended to be opaque to API clients or whether that was for the API server.
It is not intended to be opaque. I think it is useful for API clients to be able to introspect and see what other API clients have set.
And probably there will be cases where users shoot themselves in the foot and they need to be able to repair the state.
Yeah.
Yeah, this is a good way. If you somehow lose your original source object, you can look here.
Well, I think that's not the.
You should never do that, but you could.
Yeah, you should be keeping it in source control. But
I mean, if you're going to do like a get, edit, apply cycle, you should take the object out of the last applied state and not the base object for that. I mean, it's user error either way, but one of these patterns results in a disaster and the other one doesn't.
So anyway, yeah, I think we don't want it to be entirely open to users, and we also don't want to prevent them from editing it because it's an escape hatch for fixing things if they screwed something up.
Yeah. Okay.
Yeah, I think that was a good digression. David Eads was also worried about this in API machinery.
So I have a question. So aren't we afraid of the performance impact of that? Like this object may become, like all objects may become potentially pretty huge with.
So considering that, so I have two responses to that. The first is this should approximately double the size of objects because people's fields, well, there's a caveat there.
There are multiple caveats there.
Yeah, so generally speaking, if different people are using apply in the same object, they probably want to own different fields. So all told, that should add up to about twice the object size.
So this is encoded objects, or these are actually encodable using protobuf?
These are, we'll need to do some extensive testing to make sure that we don't lose like set unset if we go with protobuf.
Yeah, and one problem
even if we store them as YAML, this allows us to we control this, we can compress them if we wanted to. Right now, the last applied annotation is extremely verbose JSON and not compressed. So this should be an improvement.
And not encodable as proto. So
yeah, not encodable as proto, therefore never compressed. The one caveat, there is something I have to think about, which is if somebody runs a system that like tweaks something across all objects and never runs again, and you do this a number of times, you could end up with a bunch of different workflow IDs that are just sitting there taking up space without providing value. So that is something that I need to think about.
Yeah, it's actually
so that is my biggest fear, actually. Yeah, but
Sorry, what? Go ahead, Wojtek.
Sorry, so I wanted to say that that's exactly my biggest fear, that there will be some ad hoc changes and that they will sit like forever in those objects.
Yeah, I also have that concern. I actually disagree that automation should be using this. I think most things should continue to use two-way merge, the regular patch. We need to fix all the merge behaviors in some new and improved strategic merge patch effectively, but I don't think that retaining the last applied states is more of a liability for those components, but the mechanism will exist, so we'll have flexibility.
Yeah, I think this is something that we can work out.
It's a matter of guidance for people who are building things as opposed to changes to the mechanism.
Yeah. So I have an entire chapter on this topic on schema changes, but briefly, I actually haven't surveyed our OpenAPI schema extensions to see which of these we've added and which of them we haven't. I think most of these we have not added, but briefly, our schema has lists which are associative, and some of them are associative on multiple keys. This means like each list item must have a unique value for that key or set of keys. And we have unions, which are mixed in with other types. Brian has a proposal to add discriminators. I don't believe any of our API types currently have discriminators.
Some do.
Some do? Okay.
We don't use it the way I think we should be using it.
Yeah. So we're still discussing that.
And so just quickly on that, my proposal is currently the API behavior, whether there's a discriminator or not, is that if multiple alternatives in the union are simultaneously specified, the user gets a validation error, which is pretty hostile. There are cases where, for example, if there's a default value and the user didn't know about it or didn't want to know about it, and they tried to then set an alternative, that they get an error. If we add a new alternative to the union, then the client can't even necessarily know that it would need to clear that particular part of the union. So the current way we deal with this is actually, in my opinion, completely broken. The two canonical examples I use are the deployment rollout strategy, where for rolling update, there is an alternative for the union, and that is populated by default. And we do have a discriminator, but if the user changes the discriminator, it does not clear the previous selection. And not all alternatives even have fields within the union. And then we have volume sources, which we keep adding more and more volume sources. Hopefully that is more or less stopping. But there's no discriminator at all. The canonical thing people want to do is switch from empty-dir to PVC. And there's just no good way of doing that really with apply today. So if we had a discriminator and the user could actually just convey their intent, I want this part to be set, then we could automatically clear the other parts. For existing APIs that didn't have discriminators, we wouldn't require it, and we would not populate it by default, because then it could drift and conflict with what the user was trying to set using the current approach. But if we could require they set it if they're using apply or for the safe mode that I proposed. And if they did set it, we would clear the non-selected parts.
Yeah, so I actually think that this can be made to work correctly with apply. But Brian pointed out that it should also not cause disasters if you use edit and get and edit.
Yeah,
so I'm still thinking about that.
Get, edit, put flows are similarly broken, as well as current patch flows. So I actually think this is a thing that fundamentally needs to be fixed in the API validation and defaulting and initialization code.
yeah, so I put together a document to try and convince Brian yesterday, but we'll see how that goes. Okay, so this is the last slide for chapter 1. I would love to have some sort of alpha in 1.11, which is why you're seeing this design before we've even released 1.10. It's hard to do too much integration in kube control without having a control plane thing, so I imagine that would come in the release after.
I mean, kube control should be pretty simple. So if we had a option, like a flag to the patch command, you could probably tunnel it through there.
Yeah, Phil was talking about, oh, you could add a command. So maybe that's just pretty easy. I mean, it is intended to be super easy for clients to call. So
so I would hope we can at least get like a special
demo
option in patch or something like that.
That'd be good. Okay, so we used 40 minutes on that. Are there questions before I go on to the next section?
Well, I just want to say that if you are really interested in this problem, Daniel's doc is really awesome. It covers a lot of use cases, and definitely a big problem with this is that even people who are working on it, even the people who built the support initially, didn't really have a complete mental model of what it was supposed to do. And that is what led to all the problems with the organic growth. And as we had turnover in terms of like who was working on the feature, things were done inconsistently and in a number of cases wrong. Like we were actually supposed to have conflict detection, but it doesn't work. We're supposed to have certain behaviors when imperative mutations overlapped with applied state, and that was initially implemented incorrectly and then later not fixed correctly it was broken in a different way. So this kind of is a repeated pattern over again where people were trying to like patch up the behavior, but almost all the fixes were in the wrong direction. So I think covering all those use cases is one of the most critical parts of this effort.
I have a quick question. I think I joined in the middle, but is this basically a proposal for a new REST endpoint, or is this only a feature in kubectl?
This is absolutely a proposal for a new REST endpoint, or rather an additional format to the existing patch.
Okay, and then is this going to be an apply verb that supports all kinds of a mix of resources, or it's only for one?
Sorry, we covered that earlier in the presentation. I'll post a link to the slides in the chat.
Sounds good. Okay.
Yeah. Okay, so I haven't actually made it to this half of the presentation in my previous runs through this deck. So and I've forgotten what slides I've made. So this could be an adventure for all of us. So this half of the problem is about actually. So the model behind apply is you look at the last thing the user sent, you look at the thing the user is sending now, you look at the live state, and you put it all together to get what the user wants now. So this is effectively a three-way merge. If you're familiar with Get's three-way merge, this is actually the structured data equivalent of that problem. Get does a great job at three-way merges, so it seems like it might be possible to do a good job on structured data, which is actually more informative than just random text. So the problem of doing this is we want to come up with a data model that can accurately represent what users want to do, but also permits a sensible difference operation, two-way merge, and a three-way merge. So this is an aside to talk about an identity. I have, if you read this document, it's rather mathematical. I think of diffing and merging in sort of algebraic terms. So this first equation, where you take a difference, you take two concrete objects, take the difference of them, and you get a patch. A two-way merge adds a single object, a concrete object with a patch, and gives you a second concrete object. A three-way merge is just a difference combined with a two-way merge. Yeah, so it's literally like one line of code, call the difference operation, call the two-way merge operation.
Yeah, and the one big difference I think with the three-way merge is not merely the application of a patch. It's that most patches that people write are additive, and the three-way merge can also be subtractive without using explicit deletion directives.
Yes. Yes. Incidentally, I may cover that later.
Okay.
So, yeah. So in the current implementation of kubectl apply, the client does the diff operation, constructs a patch in strategic merge patch format, sends that patch to the server, and then the server does the two-way merge operation with the strategic merge patch. Yeah, so that's problematic, but we'll probably come back to that. So why is this part of the problem hard? Lack of API support, client-side implementation. Strategic merge patch was not easy to version. You had to fix multiple things and wait a long time before you could rely on the fixed things. So from the beginning, I think Brian has sort of touched on this. From the beginning of this, the implications of our schema weren't well understood when we first started doing this. So the fact that we had non-positional list sets, undiscriminated unions, defaulting behavior, API behavior that wasn't friendly to declarative changes. This led to a lot of bugs. In addition to just the bugs of getting the diffing or merging wrong.
Yeah, and some bugs are still even in the API schema itself. The canonical example is ports, where port is the port number in services is specified as the merge key. But you can have both TCP and UDP ports with the same key. So really it's a case where you need multiple keys that together, multiple fields which together are the key, and the current implementation doesn't even support that yet.
Yeah, we our support for our own schema is spotty. Like we should be validating, like if you declare keys in your type, we should validate that you only have one member of that list that has those keys.
Yeah, I mean most people adding API types didn't even understand what this stuff was for, so we need to much better document that and also provide linting tools to force everyone writing lists and maps and things to specify the actual topology of the resource. So the associative lists, sets, unions are issues, but we also have need to distinguish behavior between map and actual map entries like labels and structure fields, which actually are different in the API, but not to JSON.
Yeah. So fairly large part of the work of this aspect of the problem is building out our IDL, the types that go to the open API schema, to the validation functions, like building out that pipeline and educating developers who are writing the API objects so that they can get it right. Education includes linters. In this case, I think that's probably the most effective. So given all that, I think it is best if we don't send a diff to the server. I think it's best if the server does both halves of the three-way merge. This is just best. Involves less churn, and importantly for me, like strategic merge patch grew ad hoc. I don't want to support a similar thing. I don't want to write an RFC for a patch format. That does not sound like fun to me. So I want to do all those computations in the server, and there you can change the patch representation in memory at will for whatever.
You can fix bugs in one release, like civilized people.
Yes, exactly. So Yeah, so if the server is doing the computation, then we have to figure out how, because the through merge has a base object. We have to figure out how to track this. So there's basically two options. And I include this for completeness. One option is when you do an apply, you send the server two objects, both the base and the local. If you do that, the client has to remember the base. If you have a source control system, it's there, but then you have to write something fancy to retrieve it from your particular source control system. And if you send the wrong base, you are going to have a bad day. So it's important to get that right. The other option is for the server to maintain it, which is clearly the option that I'm recommending in the first half of this. The server maintains it. The client doesn't have to remember it. You don't have to work with your source control system to do anything special when you run an apply. So I don't mention this here, but one reason why you don't want to make the client do this is that the client might be sending the same object to multiple clusters. And you don't want the client to have to keep track of not only the last thing they sent, but the last thing they sent for every cluster they sent it to. That's just an unreasonable amount of work for the client to do. And if you happen to store this in the server, then you can generate good error messages on conflicts. So server-side storage is the clear winner in my mind. So now I have a slide about our data model, and I think we've hinted at this multiple times, so I'll be brief. Our data model has a few atoms, structs, lists, maps, and leaf fields. Structs contain unions. Structs can have more than one union. Some unions have discriminators. Some unions don't. There are fields in structs that have unions that aren't part of the union, so that's complicated. And I don't know that you can represent that exactly in OpenAPI. Our lists are associative, they have keys. Our maps are basically like lists, but they're forced to have a string key, just how it's implemented. One of the problems in early versions of kubectl apply was that it scrambled the list and map order because it read it into a Go map and then wrote it out again, and Go likes to randomize things for you to make sure you don't accidentally depend on something that the Go team did. And finally, we have what I've called leaf fields. You'll see them referenced in my document as either scalars or primitives. Those are strings, numeric types, integers, or floats. I think JSON lets you encode floats as well. Booleans, atomic lists, and maps are both treated as leaf fields. And for our purposes here, strings includes both byte arrays as well as enums. So now we talk about why patches are not the same as objects. Just an example from a random example from the Go package. If you subtract 2 times, you do not get another time, you get a duration. If you subtract 2 objects, you don't get a third object, you get a movement in object space, if that makes sense. And the reason why it is not the same type is that you might be representing a deletion. And given our associative lists, you can't, like you would think, like for a map item, you can say in JSON, key : null, and you could represent a deletion that way. But for our associative lists, because you have to specify one or more fields just to get the system to understand which list item you're referring to, you can't then set that thing to null. It's not encodable. So that's the primary reason why what I've called delta schema is not the same as the object schema. Oh, I have an entire slide on that. Yes. A secondary reason is that required fields in the original schema are always optional in the delta schema because the difference object might not change them, and that's okay. And this problem is essentially why strategic merge patch had to evolve. some non-obvious details, and I put these here because they're controversial. So just to make sure that everybody sees the controversy, you cannot delete a field that is required or has a default. The delete operation simply doesn't make sense. If you delete the replicas field in your deployment, you do not get 0 replicas, you get 1 replica. It fundamentally doesn't have a delete operation. So there is this concept that everybody who's dug into this space has come up with this concept of disowning versus deletion, where disown means you merely wish to not.
You're no longer asserting a value.
Yeah. You don't have an opinion about the field anymore, and delete means you have a positive desire for this value to go away. So Brian and I both have thought of various heuristics for making the API get this correct. I think it's still not 100% clear to me whether we can come up with a heuristic that gets it correct 100% of the time, or if we need to represent it directly in the API type. So I think that's sort of TBD. And I'm going to continue to work through more examples of what all of our controllers are doing to figure out the answer to that. And we already talked about unions. I think, and this is here again because it's non-obvious, that's a very nice way of describing it. I think unions, if you set one member, that implies clearing all the others. I think you can handle that in the two-way merge logic, and it will more or less get things correct. But that doesn't handle the case where you're not going through the merge logic. So
yeah, I mean, I believe that could be true, but I would also like it to work for put.
Yeah. So we need to think about that. And the last item, and this is perhaps the most, or one of the most non-obvious things about the original apply, is that list ordering is really hard because you get lists in different orders. So if you look at my document, I have one recommended algorithm for defining the order after a two-way merge. I'm not super happy with it, but there are examples there listing what I believe that algorithm does. List ordering is also important because our lists are ordered.
So is there an example of where we do have an ordered list that matters? Like all the ones I can think of off the top of my head don't matter.
Init containers?
Yeah, init containers or environment variables are the two common cases. But just practically speaking, randomizing the order is for hostile. Yes. Often the order is curated, or if they actually just want to do a Linux diff, a textual diff on the files, we don't want to scramble everything. That's just really annoying. So ideally, the ordering would be relatively stable as much as possible. For most common cases, you're merging in, like inserting things into lists or maps, or removing them, or changing subsets of them. I don't think there are any intended cases where a patcher would actually deliberately present things in a different order than what's in the base. But we would need to deal with that case if that actually happened. We need to decide which one was the winner.
Yeah, so if you look at my document, I have like a constraint-based or like topological sort inspired approach to ordering them. For most lists, it doesn't really matter what the order is as long as it's predictable and stays the same. For some lists, the users really care a lot about the order that things appear in. And if you're in that condition, I think the best way is to, in your document, like even if you only want to own some of the init containers, but you care about the order, like you can mention the other keys in the order that you want them to appear. So I think that's the way to go about it. So the doc is pretty rigorous. I'm currently working on filling out the test vectors. Like I think it's important that we cover all of the cases here because missing cases has led to a lot of bugs and stuff. So yeah. All right, and wow, I got through the whole deck. in just under time. So thank you, everybody.
Daniel, thank you so much for being so thorough on this, because this, I think, would be hard for a lot of people to consume without the full case being made for it. So bravo, good job. If I can understand it, then you're doing well. So great, thank you. Are there any follow-ups that we need to do to help raise awareness or get more consensus building, or how do we enable you to have more success with this?
I think what I'm hoping for initially from SIG Architecture is something like, yes, this is the direction we'd like to go. Go ahead and put together the KEP or start building out the more specific concrete designs for the various things that we want to change. I think that's what I'm looking for.
Okay, great. Does anybody else have anything that they can say in 1 minute that needs to be said before you adjourn?
My short answer for Daniel is yes.
Yeah, likewise. I 100%. This is real serious technical debt that needs to be handled.
Great, thanks. This is good to hear. Yeah, look for more stuff on this topic in the future.
Great.
Yeah.
All right. Thanks, everybody. Have a fantastic rest of your day, and see you hopefully at the community meeting.